Geometry, Section 1.6, Part 2. Before we get into these four definitions, I do want to show you something real quick about the arc marks that I was using in the last lesson. We're going to get a little bit more specific about that. If I have a situation like this, we're about to learn something about this angle and this angle. Well, one day we will know that they are congruent. By using this symbol and the same symbol here, I am saying that they're congruent. I was referencing them in the last video, and I wasn't really talking about congruence because you weren't supposed to know that yet. But going forward, we use arc marks to show that angles are congruent. And it doesn't have to be like this. You know, there could be another angle that's over here. And if I go like this, well, now you know that all three of those angles are the same measure. Okay? Now, along the same lines, well, first of all, let me say this, that let's say there's another angle like this too. And let's suppose that this angle and this angle and that angle are congruent. To distinguish it from the first set, you'd want to use two arcs. And we do that, and if there was a third set, you could use 3x, and a fourth set, you could use 3 arcs, and if there's a fourth set, you could use 4 arcs. Sometimes we'll also do a little tick mark on the arc too, and that these are then all congruent angles. Okay, it's similar on segments. If I knew that this point right here were a midpoint, remember that from a couple sections ago, it would be the case that this is congruent to this, tick mark, tick mark. If we had multiples, you could do double tick marks like this. But double tick mark here and a double tick mark here would be telling us that these are congruent and that they're not necessarily congruent to some other segments that have been marked with another number of tick marks, like 1. 1 tick marks would be probably a different measure than these. Okay, so with that out of the way, let's talk about vertical angles. What I just had marked there actually are vertical angles. They're two angles whose sides are opposite rays. That definition is a little bit hard to think of, but basically it's like I just had marked. I just want to link it up with the definition there. This angle and this angle would be vertical angles. Now, one day we will have a theorem that tells you that vertical angles are congruent. That's actually coming in chapter 2. I wouldn't hide it from you though, and it's pretty obvious they're congruent. Okay, so those are vertical angles. Adjacent, so because they're going to be congruent, and I'm not hiding it from you, I'm just telling you right now, I'm just using single arc marks, okay? But that is to mark the fact that they are vertical angles. Another pair of vertical angles would be this one and this one. Again, I'll use the double arcs to show that, okay? Adjacent angles, now adjacent means next to, right? My neighbor's yard, my next door neighbor's yard is next to my yard. We have adjacent properties. And adjacent angles are defined as two coplanar angles with a common side, a common vertex, and no common interior points. So something as simple as this. This angle and this angle would be adjacent angles. Now I'm careful to mark those differently, one with one arc and one with the second arc, because I don't know that they are congruent, okay? But they are adjacent. The two marked angles are the adjacent angles. Let's consider a couple of other options. Why do we have to have such a specific definition here? Well, another thing that we'll talk about in chapter 2 is the need for good definitions, and this is a very good definition. And let's consider what this might look like if it didn't have a common side. If it was two coplanar angles, but they didn't have a common side. Something like this. Sorry for the messed up arrowhead there. Would this angle and this angle be adjacent? No, they would not. They don't have a common side. They do have a common vertex. They don't have any common interior points, but they don't have a common side because this side that forms the angle doesn't help to form this angle, and this side to form this angle doesn't help to form this one. So these would not be adjacent. What if they didn't have a common vertex? I can think of an example that would look like that too. What if we had something like this? Two angles, and they were like this. This angle and this angle. Are those adjacent? They have, they're coplanar. They have a common side, right? This is a common side here. They both, it helps to form both angles. They don't have any common interior points, but they don't have a common vertex. So these would not be adjacent angles either. Let me give you one more example. What if no common interior points? What would that look like? Well, go back to that similar drawing to the one that I just had for the first example, if you will. What about this angle and this angle? They have a common vertex. They really don't have a common side either, but they also share some interior points here, and that can't happen. So none of those, all three of those examples, none of those are adjacent angles, only something that looks like this. Okay, moving on. You've probably heard this word before, but let me just make sure. Complementary angles, those aren't angles that say nice things about you. Complementary angles are angles that add up to 90 degrees. They do not need to be adjacent. They can be, but they do not need to be adjacent. A common way would be to show a 90-degree angle. Something like this. And this little block here suggests a 90-degree angle. And if there's some ray like this, and this is angle 1 and this is angle 2, yeah, okay, they're complementary angles. No doubt, angle 1 and angle 2 do add up to 90 degrees. But how about this? What if we had an angle like this, and it was 33 degrees, and then we had another angle over here, and it was 57 degrees? Those are complementary angles too. They don't need to be adjacent. 33 plus 57 is 90 degrees, and those are complementary. Much the same with supplementary angles, except the sum is 180. A common way to see this, of course, is, yeah, they would be adjacent angles like this, right? And I really don't need to give you any measurements with this one. You would not be confused by this straight angle, okay? There's a straight angle with a vertex right here. No doubt that this angle and this angle are supplementary. But just the same, I could draw them separately and give you angle measures. And if they have a sum of 180, then they are, in fact, supplementary angles. Okay, a little bit more about language, and then we'll just got to do 2 examples and we're done. You'll see this in the book. Complementary angles, that's one way to say it. Okay, angle A and angle B are complementary angles. The other way to say that would be to say that angle B is the complement of angle A. Okay, so they'll change that, the wording just a little bit. Don't be confused by that. You see any form of the word complement, we're talking about 90 degrees as a sum of 2 angles. So angle 1 is the supplement of angle 2. That means that they are supplementary angles. Okay, so an example. Name all pairs of angles in the diagram that are vertical angles. So you can see that angle 1 and angle 3 would be vertical angles. You should be able to see that angle 2 and angle 4 would be vertical angles, right? And there you go, angle 1 and angle 3, angle 2 and angle 4. What about supplementary angles? Supplementary angles would be the green ones, right? Angle 1 and angle 4, they would be supplementary. The black ones, angle 2 and angle 3, is that it? Wouldn't also angle 1 and angle 2 be supplementary? Angle 4 and angle 3 would be supplementary. So we have 4 pairs of supplementary angles here. And yes, they are also adjacent. We already made that point, though. They do not have to be. And there they all are listed. What about complementary angles? Name a pair of complementary angles on this figure. Well, there aren't any, okay? And someone might suppose that angle 1 and angle 3 are complementary angles. You do not know that. This is not a situation where we would get the protractor out. This is not that part of this, this lesson. So this is not a situation, because quite honestly, and you've now practiced with the protractor, do you know the difference between a 45.01 degree angle and a 45.04 degree angle? That would not be visible to the naked eye. So we don't know that. This problem did not say take out your protractor and measure. And angle 1 might look a little bit like a 45, and angle 3 might look a little bit like a 45, but even still, they could be 46, and you wouldn't be able to tell. So there are no complementary angles here. We have no information that anything would add up to, any of these would add up to 90 degrees as pairs. All right, one more example. It says, use the diagram. Which of the following can you conclude? That angle 3 is a right angle, Let's just take them one at a time. Could you conclude that angle 3 is a right angle? I see no information that would cause angle 3 to be a right angle. And when I do this problem in class, I have had students say it looks like an obtuse angle. I agree, it looks like an obtuse angle, but this is also not the place where we should look and try to just say, I think it kind of looks like. I mean, we want to go with information, and the information is that there just isn't any information to conclude that angle 3 is a right angle. Okay. What about angle 1 and angle 5 are adjacent? Well, look at your definition. Angle 1 and angle 5, do they have? Are they coplanar? I didn't really emphasize that in the notes, but coplanar would mean they're drawn on the same plane, probably your computer screen, right? They are coplanar. Do they have a common side? Angle 1 and angle 5, they do have this as their common side right here. Do they have a common vertex? Same vertex right there. That point right there is the vertex of both angles. Do they have any common interior points? No, they do not. So actually, this is going to be the answer. Angle 1 and angle 5 are adjacent. Now let's just rule out the other one too before we end the video, and that is angle 3 congruent to angle 5? Remember the symbols here. Angle 3, the angle symbol, we've been using that for a while now. The congruence symbol, are they congruent angles? Do they look like they have the same measure? In fact, no. Opposite rays, if you look at your vertical angle definition, opposite rays would be like this one and this one. And then the other angle the other ray that forms angle 5 is this one with this one. Well, that's not angle 3. That was this. That was the sum of angle 2 and angle 3. Think angle addition postulate. So this is not true, neither is this true. Only angle 1 and angle 5 are adjacent is true. The last thing I want to tell you is that number 32 on the homework uses the word bisect. I can't remember if it's bisect or bisects plural or bisector, but in any case, that word means to cut in half. Okay, so if something bisects an angle, if I told you that this ray that I'm about to draw bisects the angle, well, then you would know that these two angles are congruent. If I told you that here's a segment and there's a line that bisects it, and it does not have to be perpendicular, it can cut through like this. If you're told that this is a bisector, you could immediately conclude that these two segments are congruent. And usually when I talk about that, somebody will bring up the fact, well, we already have the word midpoint. What do we need bisector for? Well, midpoint is the point right here. The bisector is a line or a line segment or a ray. Okay, a bisector is a line segment or a ray. The midpoint is a point. So the midpoint is the point where the bisector passes through. They're different things. All right, thanks for watching.